In this presentation, we're going to talk about event-driven steering. Steering of roaming is the main tool available to operators to control where their subscribers roam and the type of experience they have when they roam. So we're going to look today at the event-driven steering concept used by Cellusys and how this can match the challenges we face today in roaming. In roaming, we see complexity is rising. We see new emerging technologies being adopted like 5G and VoLTE. We see lots of different types of networks like private networks and MVNOs, and in particular then IoT. We have a huge diversity of use cases, so especially driven by IoT. Lots of different IoT devices with different needs that don't necessarily behave the same way as regular consumers and that have different needs than regular consumers. So overall complexity is going up significantly. But at the same time, our resources to manage complexity are not going up. In general, budgets are not growing. Expertise is hard to find. So to manage this complexity, we essentially have to do a lot more with a lot less. And automation is the key to doing this, to reducing that dependency on our dwindling resources. If we go back, let's say 15 years ago, and look at roaming complexity or quality assurance back in those days, it wasn't very difficult. If a subscriber got registered to a VLR, for example, that meant they had voice and SMS service. That was the entirety of service, so everything just worked fine. And your steering system would make sure you got attached to a VLR and you therefore had complete roaming service as you knew it. But nowadays, the quality of this roaming experience is impacted by a lot more factors. Sure, the steering system will still make sure you get to the VLR or SGSN or MME. And that's a good start. Nothing will work without that, obviously. But even when we get to that point, we then have to establish a GTP session for data. We have to establish another GTP session for VoLTE. We have to get a registration to the IMS for VoLTE as well over SIP. And these are all failure points that are not typically managed by steering, but they will be perceived as no service or bad service by the roamer. Similarly, things like data speed, data achieve, or any kind of control plane failures as well could affect voice, SMS, or data. So there's lots of breaking points in networks now that is not explicitly managed by steering, which is usually just managing the mobility part of it. If we look at what we have today to address this problem, almost every operator will have a steering system. It will have lots of functionality. It'll probably work quite well, but it's generally manually configured. Operators often have analytics as well, and these again might be quite good, but generally they're passive. So they might highlight issues, but they don't do anything about them. If we consider maintenance of quality as well, we have some view on quality as well. Again, in the analytics, we might have things like GRQ, global roaming quality, but they don't go deep enough. They look at the network level, but that's not really enough anymore. We have to look at the subscriber level to maintain quality going forward. But we do have lots of tools here, and we can see ultimately the issue is that humans are bridging the gap between these. For example, my roaming engineer might spot an issue on the analytics system, but take action on the SOR system to fix it. So this human interaction is what we want to replace with an API-driven approach. Using APIs, we want to turn our analytics into some kind of action automatically. The other big point we have to consider is we have to look at per subscriber resolution. As I mentioned earlier, with IoT especially, there's a big diversity in use case, and the solution or problem for one roamer won't be the same as another. So we can't just solve this on the network level or for a big group. We have to focus on per subscriber resolution. So we are talking here in event-driven steering largely about steering to quality. And steering to quality is not a new idea or a new concept. It's existed for quite a long time. But it typically means using something like the global roaming quality metrics, the GRQ metrics. This gives us relative scoring of the quality of different networks. This can be used by steering to decide network A has better quality than network B, therefore we should steer towards network A. That's the general concept of steering to quality. This is often done through active testing through probes located around the world. And this does have a lot of value to give us an idea on what kind of quality we can expect. But we do have to also recognize the limitations of this approach. Not all use cases are captured. So we're limited by the diversity in coverage. So where the device is located, the probe, we can get a good idea what's going on in that location, but that might not be representative of what's going on elsewhere in the same market. So while the probe might have a good experience, your subscriber in a remote location may not have a good experience. It's also the case that they're limited in the diversity of handset type. So we have lots of different consumer handsets, but more to the point, we have lots of different IoT devices as well. They all behave a bit differently. They all have different success criteria. What's important for an IoT device won't necessarily be what's important for a consumer. So with all that in mind, in this blue box really is the essence of what we're getting at here. We have to focus on the specific challenge faced by the specific roamer at this specific moment in time. We can't just look at a G or Q score for a network. We have to look at the actual individual roamer and consider what problems or challenges they face and come to a resolution just for that one subscriber. All this brings us to what Cellusys advocate as the optimal steering approach. And we classify this in two ways. We talk about preemptive steering and corrective steering. Preemptive steering is where we make an upfront decision. So imagine we have a subscriber who just has arrived in a country for the first time, and we want to decide which network do we want to put them on. Often that might be the network with the best price, but could also be driven by G or Q scores, or really any other metric we want. But the point is really, whatever we choose for whatever reason, there's a minimum level of quality they need to have. So we have to ask, when we put a subscriber onto a network, do we reasonably expect that they're going to be well served by this network? And the more information we can feed into steering to make that decision, the better the decision we make is going to be. So for example, knowing who the subscriber is. Are they an IoT device? What type of handset are they using? What are their historical roaming patterns? Are they usually silent? Do they use a lot of data? All this will help us choose the most appropriate network up front. But no matter how well we choose the network, there will still be cases where some subscribers roaming are going to have service issues. And in these cases, we have to correct this with steering as well. So we push the subscriber to a network expecting it would work fine. But when they got there, we find there's actually an issue. They're unable to use data. They're unable to register for VoLTE, for example. So we want to take an action when this happens to steer that subscriber to a different network in the hopes of resolving that issue. And again, this is per subscriber resolution. Just because one subscriber had a problem on the network, we don't have to steer everybody else away. We can just solve it for this one subscriber. And this is the essence of event-driven steering. The analytics system generates events. So an event can be anything that happens. It can be my subscriber failed to register for VoLTE. My subscriber failed to establish a data session. My subscriber has used no data in the last 6 hours. This network, my partner network, has had a high failure rate on session creation for the last 6 hours. Whatever it might be, we create the event, we forward it into steering. Steering then has to make a decision. Does that event warrant action? Again, this is automatic decision making. If we interpret the event and decide it warrants some action, we then make a decision on the per subscriber level how we're going to solve that. So going a bit deeper again. In this case, we've preemptively steered a subscriber to a network. We expected everything would work fine. But then we get an event from the analytics saying, subscriber X failed to establish a data session in network A. So that event comes to steering. Steering interprets the event and decides the action is steer that one subscriber away from this network. So don't steer anybody else, just this one subscriber. They're not compatible with this network. Let's steer them somewhere else. And steering applies that and we move the subscriber away. So actions we take can be things like that. Steer one subscriber away, allow that one subscriber to attach anywhere, steer all subscribers away from a network if the event tells us it's a network level issue. Looking at the architecture for this then, you'll see the analytics here, which is looking at all roaming protocols. So this is the Cellusys in-house analytics system. It's generating events like silent roamer, Vaulty failure, data failure. These are just some examples. Events can be anything we want. So by combining our steering system with our analytics, we are offering an out-of-the-box, turnkey, event-driven steering solution. Now, it's worth noting that if you already have some data in your network, you have analytics you like already, you can reuse those. So you can use events from an existing platform, send them to our steering system, and we can interpret them just the same. So you don't have to necessarily take the entire turnkey solution. You can reuse parts of what you have as well, along with our steering. So going a tiny bit deeper again, here we have our analytics, Roam Insight. It's looking at all the protocols. So it sees a subscriber ultimately try to register to the IMS and fail. So it forwards the event to steering to say, this subscriber had a failure registering for Vaulty. So steering can interpret this and say, this subscriber is not provisioned for Vaulty, therefore not Vaulty capable. And if my visited network is Vaulty only, I'm going to steer away. I'm going to steer that subscriber somewhere else. I can still steer other subscribers to that network, just not this one subscriber. So over time, events will come in. So this is what it looks like. So we have the event stream here. So things like Vaulty registration failure, a high network data failure rate, silent roamer detected. These are all events we can take actions based on. So when we receive the event in, we put it through our event broker. So the event broker has to be flexible to interpret the event and take whatever action that the customer wants. Every network will be different, so we need this flexibility. So this example, which is quite contrived, if it's a silent roamer event, I'm going to add them to a silent roamer group so I can steer them differently going forward, unless they were in Austria or Ireland, just as an example of the flexibility and granularity that you need for interpreting events. So then the action we take based on matching that criteria, we add this subscriber to the silent roamer group. So we call the existing API in the steering system to add a subscriber to that group. So this IMSI, next time we see him, will always be classed as a silent roamer. We can take different steering actions for that group now. So the benefits of this should be quite clear. We're looking at automatic and instant resolution of quality issues. We're looking at operational efficiency. We're solving these issues without needing people. It's all done through APIs and automation. And in the end, that gives us a better roaming experience for the customer. Their issues get fixed without the need to complain or the need for somebody to investigate. In terms of deployment, it's ultimately cost neutral. Considering you have a steering system already and an analytics system already, if you replace them with the Cellusys systems, you can imagine the cost will be very similar. And also bear in mind that the current analytics can be reused if it can generate events for us. So you can keep your analytics and pair it with our steering and get just as good a result. So the reason we're well placed to deliver a solution like this, we're very innovation focused. We're always assessing and improving our products. We're automation focused. Everything we do looks through an automation lens. Can it be automated? Everything in our system can be automated through APIs. We have a lot of expertise in signaling. We've built everything ourselves from scratch. We've no third-party dependencies on decoders or anything like that. We build everything to be reliable and very user-friendly. And we're also have a great track record in steering. Steering is the main point of control in this concept. And we have a very strong track record in steering and are very highly rated by all independent reports there. The technology behind it is our existing steering of roaming platform, our existing analytics platform, or your own analytics if you prefer, joined together through API technology. So the events, again, use APIs to communicate with steering, and adding in a flexible rule engine for the event broker. So we have to be able to flexibly interpret the events so that we can make decisions which, will be appropriate for each specific operator. And going forward, challenges will evolve. So, we looked at some examples in this presentation of how known challenges we have today could be solved automatically in this model. We also have to be extendable. We're going to face new challenges going forward, and we want a future-proof solution. So that means The analytic system for generating new events has to be flexible. It has to be able to generate new events when new challenges arise. And the steering system has to be able to interpret events very flexibly as well. So in the end, what we want is when we have to face a new challenge and take a new action, it should be all handled through configuration. We don't want to have to develop new events or develop new actions. It should always be generic and configurable by the user to match their own specific needs. And going forward, we'll continue to deploy this model. We have some deployments out there today, looking at a limited set of use cases, some of which I've described above. But as we go, we'll be adding new events based on challenge we meet in the real world. We'll add multiple event generators as well. So the source of events doesn't have to just be technical, like the analytics and quality. They could come from things like financial forecasting, could generate events. But in the end, the steering is a single point of control for roaming, and we have just lots of points of intelligence to feed in through APIs. And the goal in the end, make any intelligence in the network actionable through event handling. And the other key point, solution flexibility. So as new challenges arise, we solve with configuration alone. And finally then, to conclude, again, the same benefits: instant resolution and automatic resolution, operational efficiency, better roaming experience, and the key to this, an API-driven approach using events to turn analytics into action, and the very key point, focusing on per subscriber resolution. So again, with the diversity of use cases we have, the solution has to be very tailored for that one subscriber to meet their specific needs.